According to the current 2023 National Electrical Code, outlets located within 6 feet of a sink require ground fault circuit interrupters, also known as GFCIs, for the following areas: bathrooms, kitchens, laundry rooms, garages, and outdoor areas. There is an exception: outlets located within a residential load center, also known as a breaker panel, are permitted to be fed from a GFCI outlet located within the same load center. Prior to the 2023 National Electrical Code, specifically in the 2017 National Electrical Code and earlier editions, the code allowed what was referred to as piggybacking of non-GFCI outlets from a GFCI outlet within 6 feet of a sink. However, this practice is no longer permitted under the current code. To summarize, according to the current 2023 National Electrical Code, all outlets within 6 feet of a sink in the designated areas such as bathrooms, kitchens, laundry rooms, garages, and outdoor locations must be GFCI protected. The only exception to this rule is load center GFCIs. This means that if an outlet is within a residential load center, it can be fed from a GFCI outlet located within the same load center. GFCI protection is crucial for preventing electrical shocks. A GFCI monitors the current flowing into and out of a circuit. If there is an imbalance, meaning some current is leaking out, it quickly cuts off the power to prevent injury. This is especially important in areas where water is present, as water can significantly increase the risk of electrical shock. The National Electrical Code is updated regularly to reflect new safety standards and technologies. It is essential for electricians and homeowners to stay informed about the latest changes to ensure electrical systems are safe and up to code. The 6-foot rule is in place because water can splash or spread within that distance, potentially creating a hazardous environment. By requiring GFCI protection in these areas, the code aims to minimize the risk of electrical accidents. When installing or modifying electrical outlets near sinks, always consult the latest edition of the National Electrical Code and follow all local regulations. If you are unsure about any aspect of the electrical code, it is best to consult a qualified electrician. They can ensure that your electrical system is safe and compliant with all applicable codes. Ground fault circuit interrupters are designed to protect people from electrical shock by detecting ground faults, which occur where electricity flows through an unintended path, such as through a person's body. GFCIs work by monitoring the current flowing into and out of a circuit. If the difference between the incoming and outgoing current exceeds a certain threshold, typically 5 mA, the GFCI will trip, cutting off the power to the circuit in a fraction of a second. This rapid response time is crucial for preventing serious injury or death. There are 2 main types of GFCIs: receptacle type GFCIs and circuit breaker type GFCIs. Receptacle type GFCIs are installed in place of standard electrical outlets and provide GFCI protection for that specific outlet and any outlets wired downstream from it. Circuit breaker type GFCIs are installed in the electrical panel and provide GFCI protection for the entire circuit. When choosing a GFCI, it is important to select one that is rated for the voltage and amperage of the circuit it will be protecting. GFCIs are typically rated for 120 volts or 240 volts and 15 amps or 20 amps. It is also important to choose a GFCI that is listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that it meets safety standards. The installation of GFCI should be performed by a qualified electrician. Improper installation can result in the GFCI not working properly or even creating a fire hazard. When installing a GFCI, it is important to follow the manufacturer's instructions carefully. Before working on any electrical circuit, it is essential to turn off the power at the circuit breaker. This will help prevent electrical shock. It is also important to test the GFCI after it has been installed to ensure that it is working properly. To test the GFCI, press the test button on the GFCI. This should cause the GFCI to trip, cutting off the power to the circuit. Then press the reset button to restore power to the circuit. If the GFCI does not trip when the test button is pressed, or if it trips immediately after being reset, there may be a problem with the GFCI or the circuit. In this case, it is important to consult a qualified electrician. GFCIs should be tested monthly to ensure that they are working properly. Regular testing can help identify potential problems before they cause an electrical shock. In addition to protecting people from electrical shock, GFCIs can also help protect electrical equipment from damage. Ground faults can cause excessive current to flow through electrical equipment, which can lead to overheating and failure. By quickly cutting off the power to the circuit, GFCIs can help prevent damage to electrical equipment. The National Electrical Code requires GFCI protection in a variety of locations, including bathrooms, kitchens, laundry rooms, garages, outdoor areas, and construction sites. These requirements are designed to protect people from electrical shock in areas where there is a high risk of exposure to water or moisture. When working with electricity, it is always important to take precautions to prevent electrical shock. This includes wearing rubber gloves and shoes, avoiding contact with water, and using insulated tools. It is also important to be aware of the potential hazards of electricity and to take steps to mitigate those hazards. Ground fault circuit interrupters are an important safety device that can help protect people from electrical shock. By understanding how GFCIs work and how to install and test them properly, you can help ensure the safety of your home or business. Always consult a qualified electrician for any electrical work to ensure that it is done safely and according to code. They can assess your specific needs and recommend the best solutions for your situation. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is important to consult the latest edition of the National Electrical Code and all applicable local codes before performing any electrical work. Staying informed about electrical safety and code requirements is essential for protecting yourself and others from electrical hazards. Remember to prioritize safety when working with electricity and always seek professional help when needed. The NEC is published by the National Fire Protection Association and it is updated every 3 years. The NEC is adopted by many states and local jurisdictions and it is used as a basis for electrical inspections. It is essential to consult the latest edition of the NEC and all applicable local codes before performing any electrical work. The National Electrical Code, or NEC, Article 210.8 specifically addresses ground fault circuit interrupter protection for personnel. It details the specific locations where GFCI protection is required to enhance safety. Within dwelling units, the NEC mandates GFCI protection for 125-volt through 250-volt receptacles supplied by single-phase circuits rated 150 volts or less to ground in various locations. These include bathrooms, garages, outdoors, crawl spaces at or below grade level, basements, kitchens, laundry areas, boathouses, and areas within 6 feet of the outside edge of a sink. In kitchens, GFCI protection is required for receptacles serving countertop surfaces. For other than dwelling units, GFCI protection is required for 125-volt through 250-volt receptacles supplied by single-phase circuits rated 150 volts or less to ground when located in bathrooms, kitchens, rooftops, outdoors, and similar locations. These requirements aim to minimize electrical shock hazards in areas where moisture or conductive surfaces are present. The NEC also addresses GFCI protection for specific appliances and equipment. For example, electric ranges and dryers may require GFCI protection under certain conditions. Additionally, the NEC provides guidance on the installation and testing of GFCIs to ensure their proper functioning. Regular testing of GFCIs is recommended to verify that they are providing adequate protection. It's worth noting that the NEC requirements for GFCI protection may vary depending on the specific application and the jurisdiction. Therefore, it's crucial to consult the latest edition of the NEC and all applicable local codes before performing any electrical work. The NEC GFCI protection requirements reflect the importance of electrical safety and the need to minimize the risk of electrical shock. By adhering to these requirements, electricians and homeowners can help create safer electrical environments. In addition to GFCI protection, The NEC addresses other aspects of electrical safety, such as proper wiring methods, grounding, and overcurrent protection. These requirements work together to ensure that electrical systems are installed and maintained in a safe and reliable manner. It is essential for electricians and homeowners to stay informed about the latest changes to the NEC and to follow all applicable codes and regulations. By doing so, they can help prevent electrical accidents and ensure the safety of themselves and others. Understanding the NEC GFCI protection requirements is a critical aspect of electrical safety. By adhering to these requirements and taking other necessary precautions, you can help create a safer electrical environment for yourself and your family. Always consult a qualified electrician for any electrical work to ensure that it is done safely and according to code. Staying informed about electrical safety and code requirements is an ongoing process. The NEC is updated every 3 years, and it's important to stay abreast of the latest changes. There are many resources available to help you stay informed, including the National Fire Protection Association's website, electrical trade publications, and continuing education courses. By taking the time to learn about electrical safety and code requirements, you can help protect yourself and others from electrical hazards. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take precautions when working with electricity and never attempt to do electrical work that you are not qualified to do. When in doubt, consult a qualified electrician.